Ionic compounds. Ah, yes, like that single aluminum atom surrounded by 3 boron atoms over there. That's great and all. We know that it forms between metals and nonmetals, but what do we call all that now? Do we just call that aluminum 3-bromine? No. Of course there's a better way of referring to these chemicals. By the end of this video, you will be able to employ the concepts and steps for naming ionic compounds, particularly for the simple binary ones. So we're not talking about transition metals here, we're not talking about polyatomic ions here, just the bare basic, simple binary ionic compound naming. But first, let's review our ionic formula steps. Whenever you are writing out an ionic formula, you need to write the cation first and then the anion second. The cation with its charge in the upper right-hand corner and the anion with its respective charge in its upper right-hand corner. So for example, Na is your metal cation with the +1, and I got that from the periodic table. And sulfur is our non-metal anion with its -2 charge up in the upper right-hand corner as a superscript. Next, we need to look at those two superscripts and see when we put them together, do they equal 0? So if I take 1 and -2 and I put those together, does that give me 0? No. No, it does not. That gives you -1. 1 minus 2 gives me -1. And I am trying to make the overall molecule, when I sandwich those two atoms together, equal 0. We want a neutral net molecule. So this is the point at which you need to do some soul searching and you need to decide, well, how am I going to fix these atoms' problems that they seem to have? And their problem is they want to be 0 and they're not currently 0, they're -1 when they're together. So we need to figure out how many atoms of each or either that we need for the whole thing to total to 0. How many atoms of Na do we need per S or vice versa in order for them to equal 0 overall? In this case, we would need 2 Na, 2 sodium atoms per 1 sulfur atom. In other words, if they are going to tango together, you're going to always need 2 Nas dancing with 1 S atom. Now that you know how many of each atoms you need in order for them to do the tango together, we're going to combine those two symbols together with the proper subscript numbers. Now the subscripts are denoting the total number of atoms that are present, not the charge anymore. So in that case, it would be Na2 for 2 sodium atoms and S1 with the invisible implied 1 because there's already an S there, so it's implying that there's already 1 there. Now that we've had some review on what to do for finding ionic formulas, how would we name that final product, Na2S? That's what we're going to find out today. Another brief reminder of the scandalous method of drop and swap. Be sure that you just write your metal cation, your non-metal anion with their charges, and the easiest way to figure out how many you need of each is to drop and swap. Put the number value from the upper right-hand corner of one at the bottom of the other and vice versa without the actual number symbol. So you don't want the plus, you don't want to take the minus, just take the number value itself. And if you end up with 1, just erase the 1 afterwards because it's implied that there's 1 there. Just like this. So what's this simple binary ionic crap anyways? Binary means 2, by 2, like bicycle, 2 wheels. So binary means 2 different atoms are present. And ionic, of course, is the bond between metal and nonmetal, as you should already know, which has an electronegativity difference between 1.8 and 3.3, typically. If we're going to name these things, we're always going to name the cation first. Cation comes first. They're so cute with their little positive charges. And the cation's name is simply the name of the element that you find on your periodic table. Nothing changes. If you're looking at N, it's nitrogen. You're looking at O, it's oxygen. If you're looking at Ca, it's calcium. If you're looking at Mg, it's magnesium. You don't change anything about it, just use the name that's already on the periodic table. Then you're going to find the anion, the negatively charged ion, and it's going to get named second. That anion is just going to end in "ide," IDE, just like we did for our covalent bond naming. But unlike the covalent bond naming, you are never, ever, ever going to see mono, di, tetra, tri, hepta, hexa, octa, nada, deca, septa, whatever. Any of the prefixes are not going to exist in ionic bond naming ever.
Oh,
So
no.
if you have prefixes, it's covalent bond naming. If you have ionic bond naming, you will never, ever, ever see a prefix. Let's see if you understood the previous steps. They're pretty simple. That's why they're called simple binary compounds. So naming this first molecule of Na and Cl, if you look at your periodic table, Na stands for sodium. Or if you prefer, sodium is Batman's element. Batman. So Na, sodium, we're just gonna write sodium. Hey, did you see that salt molecule? It's sodium fine. Then we're going to take the second atom present, which is Cl, chlorine, and we're just going to end it in "ide." So, chloride. Ta-da! We have named our first simple binary ionic compound. How about the next one? MgO, MgO. If you switch that around, it could be oh my gosh. Mg stands for magnesium, so we're just going to write magnesium. Nothing changes. It's just whatever's on the periodic table for that element's name. And the second atom present, our anion, is our oxygen. However, we do need to end it in "ide", so then it would be oxide. Next up is AlBr3. Hey, that's the thing above my head that we started the lesson with. Al stands for aluminum, or technically it's called aluminium if you're saying it correct. But I insist if you're going to say it that way, you have to say it like this. Aluminium.
Oh, no.
And Br stands for bromine. Of course, it needs to end in "ide", so we're just going to say bromide. Bruh. Notice I didn't even have to mention that there were 3 bromine atoms per 1 aluminum. That didn't matter in the naming scheme, because if you're given the name aluminum bromide and you write it out, you're going to have to figure out that there's 3 bromine atoms to balance the charge of the 1 aluminum atom yourself. So as I just mentioned before, if you're given the name and you have to figure out what the formula looks like, you have to figure out that the charges need to balance to 0 yourself. So here's the steps you should follow to do so. Number 1. Write the periodic table symbol for the first atom, the metal. Write that down on the paper. Then put its typical charge in the upper right-hand corner, just as you would before using your periodic table. Number 2. Write the periodic table symbol for the second atom, the nonmetal, and put its typical charge in the upper right-hand corner. And finally, number 3. Drop and swap, scandalous, to balance the molecular formula and get your final answer. Let's see if you get it. For sodium bromide, sodium is Na, so I'm going to write Na. And if you look at your periodic table, it is in that first column, so it has a charge of +1. And bromide is Br for bromine, and it's in the column of the halogens, so it has a -1 charge. Using our drop and swap method, I'm just going to take this one and put it down there, take that one, put it down there, and we end up with a lovely final product of Na1Br1. Now, of course, anytime you have ones there, you don't need to show the ones. They're superfluous, and it looks wrong. You're not supposed to keep them. So, NaBr. That's it. Next, calcium chloride. Calcium is Ca. I wrote the symbol first. How did Canadians name Canada, by the way? They just threw a bunch of letters in a hat and each pulled one out. The first one pulled out a letter and they said Ca, and the next one pulled out a letter and said, oh, Na, and the third guy pulled out a letter and said, Da, and hence we have Canada. So it all started with calcium. You're welcome. Calcium, Ca, has a +2 charge, and chloride is chlorine, so that Cl has a -1 charge. We're going to drop and swap. Put the 2 at the bottom of the Cl, put the 1 at the bottom of the Ca, and you get a Ca1 and a Cl2. Again, don't keep that 1 down there on the Ca. It's already implied because there is a Ca already, so just ignore that 1, and your final answer is CaCl2. And now is the time to pause the video to see if you actually understand the words that are coming out of my mouth. So first things first, name the following simple binary ionic compounds, Ki, CaF2, Na2S, and write the molecular formula for the following ionic compounds, lithium selenide, aluminum oxide, magnesium bromide. Ready? Go! Let's check your answers, see if you got them right. Ki, K stands for potassium, so you would just write potassium. I stands for iodine, and we just have to end it in "ide" now, so it would be iodide. I heard this joke once that was so funny, iodide. Aww. Next is CaF2. Ca stands for calcium, brought to you by Canada. And F stands for fluorine. We just need to end fluorine in "ide, and we have fluoride, calcium fluoride. Last one is Na2S. Na stands for sodium, so we'll just write sodium. S stands for sulfur, and it needs to end in "ide" now, so sulfide. And we're done. The molecular formulas tend to be a little bit more tricky. Let's see if you got these right. First, write out our atoms and their respective charges. We have lithium is a +1, and I got that from the periodic table. Selenide is Se, and Se is in the same column as oxygen. That means it would have a -2 charge. Let's drop and swap. We end up with Li2, Se1, but I'm just going to leave the 1 off. We have aluminum oxide. Aluminum is Al, and that has a +3 from the periodic table. Oxide is oxygen. It has a -2. Drop and swap. We have Al2O3. And last, we have magnesium bromide. Magnesium is Mg. Magnesium has a +2 charge from the periodic table, and bromide or bromine is Br, and it has a -1 charge. If we drop and swap those two numbers, we end up with Mg1, again just leave off the 1, and Br2. So in summary, here is an example of what simple binary ionic naming looks like. You're always going to have the cation with the anion ending in "ide." And an example of magnesium and chlorine. Chlorine's the anion, so it should end in "ide," chloride, magnesium, chloride. And you're always going to have your cation first, your metal will come first, which is the cation, and your nonmetal, your anion, will always come second. Now make sure you test yourself before you wreck yourself, and see if you can name or show the molecular formula for the following list of test yourself questions. Post your answers in the comments below, and I'll be sure to tell you if you got them right or not. And while you're commenting, I'm also quite curious, just for funsies here, if you had to choose for the rest of your life to either sleep standing up or enter your car through the passenger side window for the rest of your life, which would you rather do? Comment below, let me know. Give me a quacks up and subscribe for more educational content. See you later.
No ducks, no glory.